Hey guys, welcome to section 4.5, which is called solving polynomial equations. We're actually going to solve polynomial equations various ways, but today we're going to focus on solving polynomial equations by factoring. Before we get to that, let's talk about the terms solutions and zeros. These should sound familiar, but let's read this paragraph. Recall that finding the zeros of an equation is simply solving the equation when it's set equal to 0. Thus, solutions to a polynomial equation are also called zeros. You can use the zero product property like we have with other factorable quadratic equations, and let's do it. So, once we start getting in here, you will definitely remember the zero product property. Remember, if we have a couple factors and they're multiplied by one another, if one of them equals 0, that would make everything equal 0. Basically, anything times 0 equals 0. So when we solve by factoring, that's the property we are going to use. So looking at example 1, part A, 2x cubed minus 12x squared plus 18x equals 0. Just like any factoring problem that wasn't solving, the first thing we look for is a GCF. Now, and look at 2x cubed minus 12x squared plus 18x. I see all of those are even numbers and they each have an x. So I can take out a 2x. And that leaves me with x squared minus 6x plus 9. Okay, and now I ask myself, can I keep factoring? And yes, I can. X squared minus 6x plus 9 is a perfect square trinomial. It factors to x minus 3 times x minus 3, which you can also write as x minus 3 quantity squared. Now, make sure you keep writing equals 0 on the right because this is an equation and we cannot lose that equal sign. Now, one thing I want to note is that this 2 out front is not part of this x. This is 2 times x minus 3 quantity squared. So whenever you have a constant that's being multiplied, you really can, if you want, divide both sides by that. So on the left, that's going to cancel. And on the right, 0 divided by 2 is still just 0. So x times x minus 3 quantity squared equals 0 is an equivalent equation. And my factors are x. I'll set that one equal to 0, and that gives us our first solution. And then I have x minus 3. When I set that equal to 0, I get positive 3. And that is my other solution. The fact that that factor is squared just means that that has a multiplicity of 2, right? Remember that word shows up twice, or it's a double 0. All right, let's move on to letter B. 4x to the 4th minus 40x squared plus 36 equals 0. First things first, let's see if there's a GCF. And there is. We can take a 4 out of everything here. So if we take a 4 out, I have x to the 4th minus 10x squared plus 9. And remember that we can divide away any constant being multiplied. So I'm just going to do that right away in this one so I don't have to worry about it. So there goes my 4, and now I'm just left with x to the 4th minus 10x squared plus 9 equals 0. Now, this is a situation of one of those factoring cases where I can write them in quadratic form. While this is a degree 4 polynomial, I know that x to the 4th is the same thing as if I would square x squared. In addition, that x squared is my term in the middle, or my variable in the middle term. And what I can do is, in place of x squared, I can say, let u equal x squared. So I can write this equation, I'm going to come up here, just using u's and make it more easy to factor. So u squared minus 10u plus 9 equals 0. And now I can just think of it as a quadratic trinomial and ask myself, what multiplies to positive 9 and adds to negative 10? Well, those will both have to be negative, be a negative 1 and a negative 9. So I'm going to write u minus 1 times u minus 9 equals 0. And now I'm going to plug back in my x squareds in for those u's, since that's what they were holding the place of. So I have x squared minus 1 times x squared minus 9 equals 0. Oops. Minus 9 equals 0. And then we ask ourselves, Are we done factoring or can we keep going? And you can actually keep going here because these are both differences of squares. So x squared minus 1 factors to x plus 1 times x minus 1. X squared minus 9 factors to x plus 3 times x minus 3. Whew, so we have 1, 2, 3, 4 factors, which means we have 4 zeros or 4 solutions to this equation. We have x equals negative 1, x equals positive 1, x equals negative 3, and x equals positive 3. And finally, let's look at letter C. 5x cubed minus 40x squared equals negative 80x. Now, the first thing I hope you know is that we have to set this equation equal to 0. After all, we are finding the zeros. And in order to factor, we need it set equal to 0. So I'm going to add that negative 80x over here with my other term. So I have 5x cubed minus 40x squared plus 80x, and then that equals 0. Now I'm going to look for my GCF, 5x cubed minus 40x squared plus 80x. Looks like 5 goes into all those, and they each have an x term as well. So I'm going to take out 5x, which just means x squared minus 8x plus 16. And that is another perfect square trinomial, which would be x minus 4 quantity squared. And I do have this 5 out front, which I could have divided away earlier, but right now, says remember, this is 5 times x minus 4 quantity squared. If I divide both sides by 5, that just gets rid of that coefficient out there, and I end up with just x times x minus 4 quantity squared equals 0. And that leaves me with x equals 0 and x equals positive 4, which we know shows up twice, but only 2 unique solutions for this particular problem. And that is solving polynomial equations by factoring.